Hello students, let's continue the session on triangles. In previous session we started with exercise 6.5. We have solved 3 questions. Let's continue from 4th question onwards. The 4th question is, ABC is an isosceles triangle, right-angled at C. Let me draw an isosceles right triangle. So this is a right-angled triangle, right-angled at C. We need to prove that AB square is equal to 2 times of AC square. Given that it's an isosceles triangle, given triangle ABC is an isosceles, so AC is same as the length BC. By Pythagoras theorem, we have AB square, hypotenuse square, is sum of the squares of the remaining two sides. Now instead of AC I can consider BC, and instead of BC I can take AC. So instead of BC I'll take AC, so that I get the result AB square is 2 times of AC square. Hence we have proved it. Very simple question. Question number 5, it's a converse of the previous question. ABC is an isosceles triangle with AC is equal to BC. If AB square is equal to 2 times of AC square, prove that ABC is a right angle triangle. So it's given that AB square is 2 times of AC square. Let's go back to the previous step. AC square plus AC square. Now AB square will be equal to AC square plus, instead of AC square I'll write BC square, because AC is given equal to BC. These three sides satisfy Pythagoras theorem. Therefore, triangle ABC is a right triangle. And right angled at angle C. The reason is the angle opposite to this side AB will be the right angle. So angle C will be the right angle. Question number 6. ABC is an equilateral triangle with side 2A. Find each of its altitudes. Let me draw an equilateral triangle ABC. Suppose if I draw altitude from the point A to the opposite side BC, let AD be the altitude, I need to find the length of the altitudes. Here they have given each side as 2A units. Remember, in an equilateral triangle, the altitude will bisect the opposite side. These two sides will become equal. They become A units each. Now, the length of AD we need to find. I'll make use of Pythagoras theorem in triangle ADC. In triangle ADC, angle D is 90 degree. I'll consider the hypotenuse as AC. AC square will be equal to the sum of AD square plus DC square. AC square is 2A whole square equal to AD square plus, instead of DC I'll consider A square. So AD square we get it as 3 times of A square. So AD will be root 3A. Therefore, the length of each altitude is root 3 A units. Question number 7, it's related to a rhombus. Prove that sum of the squares of sides of rhombus is equal to sum of the squares of its diagonals. Let me consider a rhombus. Say the name of the rhombus is ABCD. These are the sides and the diagonals. We all know that diagonal of a rhombus bisect each other perpendicularly. This concept is known to us. So let me mention that we know that diagonals of a rhombus bisect each other perpendicularly. Since the diagonals bisect each other perpendicularly, there are 4 smaller right-angled triangles. So one of the right-angled triangle, let me name the point of intersection as O. One of the right-angled triangle is triangle AOB. In this triangle AOB, the side AB is the hypotenuse, so AB square will be equal to OA square plus OB square. Let me name this as 1. And in triangle BOC, we have BC as the hypotenuse, so BC square will be equal to OB square plus OC square. Let me name this as equation 2. In triangle DOC, DC is the hypotenuse, so DC square will be equal to OD square plus OC square. This is equation 3. Similarly, in triangle AOD, we have AD as the hypotenuse, AD square will be equal to OA square plus OD square. This is equation 4. These all we have obtained by Pythagoras theorem. Now, if you add equation 1, 2, 3 and equation 4, we will be getting the left hand side as sum of the squares of the sides of the rhombus. This is equal to, if you observe properly, we have got 2 times OA repeated, same as the case with OB, OC and OD. So I'll write 2 times of OA square plus OB square plus OC square plus OD square. What is the sum of OA square plus OC square? OA and OC, they are equal because the diagonals bisect each other. So OA equal to OC and OD will be equal to OB. So I'll write this as twice of, instead of OA and OC, I'll consider OA only 2 times, so 2 times of OA square plus 2 times of, instead of OB and OD, I'll consider 2 times of OB square. So we get the result as 4 times of OA square plus OB square. OA and OB, they are the parts of the diagonal. If you recall, the diagonals bisect each other. Instead of OA, I can write it as AC by 2. So I'll get 4 times of AC by 2 whole square plus, instead of OB, BD by 2 whole square. Further, if you simplify, we get AC square plus BD square. This is the sum of the squares of diagonals. So hence we have proved that sum of the squares of the sides of rhombus is equal to sum of the squares of its diagonals. Hence we have proved. Question number 8, very important. This question has been asked several number of times in the examination. O is the point in the interior of the triangle ABC. OD perpendicular to BC, OE perpendicular to AC, OF perpendicular to AB. Show that OA square plus OB square plus OC square minus OD square minus OE square minus OF square equal to AF square plus BD square plus C square. And also second one we need to prove is AF square plus BD square plus C square equal to AE square plus CD square plus BF square. If you observe here, OA, OB and OC, they are required. So let me join OA, OB and OC. I'll join them by dotted line. OA, OB and OC are joined together. Let's do the first one. I'll consider the triangle AOF. In this triangle AOF, it's right angled at F. So AO will be the hypotenuse. So OA square on the hypotenuse equal to sum of the squares of the remaining two sides, OF square plus AF square. Let me call this as equation 1. Look at the triangle BOD. In this triangle BOD, angle D is being 90 degree. OB will be the hypotenuse. OB square will be equal to OD square plus BD square. This is equation 2. And also you observe the triangle COE. It's right angled at E. So OC will become the hypotenuse. So OC square will be equal to OE square plus EC square. Let me name this as equation number 3. These three are obtained by Pythagoras theorem. Let us add the equation 1, 2 and 3. Let's add equation 1, 2 and 3. What do we get? We get the left hand side as OA square plus OB square plus OC square, which is equal to OF square plus AF square plus OD square plus BD square plus OE square plus EC square. What I can do is I'll retain AF, BD and EC. Rest of the things I'll transpose to the left hand side. So this implies OA square plus OB square plus OC square minus OF square minus OE square minus OD square equal to AF square plus BD square plus EC square. Observe what is the first one is the same. OD, OF, OE, their squares are being subtracted from OE square plus OB square, OC square, and we get the result as AF square, BD square and CE square, same as EC square. Hence we have done the first part. Let's do the second part now. For proving the second part, I'll use the result of the first part. I'll mention from previous result. We have AF square plus BD square plus C square as OA square plus OB square plus OC square minus OD square minus OE square minus OF square. Let me rearrange and group them as OA square minus OE square plus OB square minus OF square plus OC square minus OD square. Why did I do like this? OA is the hypotenuse minus OE square will give AE square. We get AE square plus, instead of OB square minus OF square, we can write BF square. Instead of OC square minus OD square, we can write CD square. So hence we have proved the second part also. Let's take up the ninth question. A ladder 10 meter long reaches a window 8 meter above the ground. Find the distance of foot of the ladder from the base of the wall. I'll draw a rough figure representing the situation. Let me mention this as a right angle triangle. Here AB represents the ladder, which is 10 meter. OA represents the wall. Here the shadow is OB. In triangle AOB, angle O is being 90 degree. We can use Pythagoras theorem. Square on the hypotenuse is AB square equal to OA square plus OB square. AB square is n square, which is equal to 8 square plus BO square. So we can find BO square, which is 100 minus 64. So BO is root of 36. The difference is 36. So the BO length is 6 meter. Therefore, the distance of the foot of the ladder from the base of the wall is 6 meters. Question number 10. The question 10 is, a guy wire attached to a vertical pole of height 18 meter is 24 meter long, and a stake attached to the other end. How far from the base of the pole should the stake be driven so that the wire will be taut? Let me draw a figure connecting the situation. It's a right triangle. Let OB represents the vertical pole. This is the stack, 24 meter, and 18 meter is the height of the pole. If you observe in triangle AOB, we have AB square equal to OB square plus OA square. So 24 whole square equal to 18 square plus OA square. So we can find OA square as 576 minus 324. So OA will be under root 252. We get the length of OA as 6 root 7 meters. Therefore, the distance of the stake from the base of the pole is 6 root 7 meters. Question number 11. An airplane leaves an airport and flies due north at the speed of 1000 kilometer per hour. At the same time, another airplane leaves the same airport and flies due west at the speed of 1200 kilometer per hour. How far apart will the two planes after 1.5 hours? It is something like this. North, south, east, west, these are the directions. Something like A, B, the distance traveled by first aeroplane due north in 1.5 hour is 1000 kilometer per hour. Should be multiplied with the time. We get the total distance as 1500 kilometer. So this distance is 1500 kilometer, and the distance traveled by second aeroplane due west in 1.5 hour is 1200 to be multiplied with 3 by 2. We get it as 1800 kilometer. So this distance is 1800 kilometer. We need to find out the distance of AB. So in the figure, AB represents the hypotenuse, so side of square on the hypotenuse will be equal to sum of the squares of other two sides. I have to mention this O here. So AB will be under root OA square is 1500 square plus 1800 square. Fifteen square is 225 and 18 square is 324. So we need to add them. The addition gives 549 followed by 4 zeros. On simplification, we'll get it as 300 root of 61 kilometer. This is the distance between the two aeroplanes. Question number 12. Two poles of height 6 meter and 11 meter stand on a plain ground. If the distance between the feet of the poles is 12 meter, find the distance between their tops. One of the pole I'll name it as AB, another pole I'll name it as CD. The height of these two poles are given. The height of the pole AB is 6 meter and the height of the pole CD is 11 meters. Let me draw a horizontal line. The distance between these two poles is 12 meter. We need to find the distance of their tops. We need to find the length of AC. Let me mention the point wherein we have drawn horizontal. Let this point be P. So I can find out the length of CP. CP will be 11 meter minus 6 meter. We get it as 5 meter. So in triangle ACP, angle P is 90 degree. So by Pythagoras theorem, AC square will be equal to AP square plus PC square. AC square will be equal to AP square is 12 square plus PC square is 5 square. We get AC as root of 169. This will be nothing but 13 meters. So the distance between the tops of the two poles is 13 meter. Question number 13. D and E are the points on the side CA and CB respectively of triangle ABC right-angled at C. Prove that AE square plus BD square equal to AB square plus DE square. Let me draw a rough figure. It's a right-angled triangle, right-angled at C. D and E, they are the points on the side CA and CB respectively. So let me mention the point D and E. Let me join BD and AE. In the to be proved, we have DE also. Let me join this. There are a few right angle triangles here. First, if I consider the triangle ACE right angled at C, the hypotenuse is AE, so AE square will be equal to AC square plus CE square. Let me name this as equation 1. In triangle BCD, we have BD square equal to BC square plus CD square. This is equation 2. Now if I consider the sum of these two equations, equation 1 added to equation 2, we get AE square plus BD square as AC square plus CE square plus BC square plus CD square. Let me name this as equation number 3. Same way, I'll consider the triangle CDE. In this triangle CDE, the hypotenuse is DE, so DE square is CD square plus CE square. Let me name this as equation 4. In triangle ABC, the hypotenuse is AB, so AB square will be equal to AC square plus CB square. Let me name this as equation number 5. Observe equation 3, 4 and 5. What do we get? We get DE square plus AB square will be equal to AE square plus BD square. This is what is to be proved since we have done that. Let's solve question number 14. The perpendicular from A on side BC of triangle ABC intersects BC at D such that DB is 3 times of CD as shown in the figure 6.55. Prove that 2 times of AB square equal to 2 times of AC square plus BC square. Again, we shall make use of Pythagoras theorem. Let me consider the triangle ACD. In this triangle, we have AC square equal to AD square plus DC square. If I want only AD square, I can write it as AC square minus DC square. Let us name this as equation 1. In triangle ABD, AB square equal to AD square plus BD square. This implies AD square as AB square minus BD square. Let's name this as equation 2. From equation 1 and 2, we get AD square present on left hand sides. I can equate the right hand sides. AC square minus DC square will be equal to AB square minus BD square. It's given that 3 times of DC is DB. Therefore, DC will be BC upon 4 and BD will be 3 times of BC upon 4. Let me name this part as equation, this as equation 3 and this as equation 4. From equation 3 and 4 we get AC square minus BC upon 4 whole square equal to AB square minus 3 times of BC upon 4 whole square. We need to simplify this. We can cross multiply the denominators after taking LCM. We will be getting 16 times of AC square minus BC square equal to 16 times of AB square minus 9 times of BC square. If you bring all terms together, now AB to the one side will be getting 16 times of AB square equal to 16 times of AC square minus plus BC square. It becomes plus 8 times of BC square. You can take 8 common here, or you can divide throughout by 8. We'll be getting 2 times of AB square equal to 2 times of AC square plus BC square. Hence we have proved it. Question number 15. In an equilateral triangle ABC, D is a point on side BC such that BD is equal to 1/3 of BC. Prove that 9 times of AD square equal to 7 times of AB square. This question is considered to be very important. So many times it has come in the examination. We have to consider an equilateral triangle. Let me draw a rough figure. Suppose if this is an equilateral triangle ABC, D is a point on BC such that BD is 1/3 of BC. We'll do a construction. To use Pythagoras theorem, I require a right angle triangle, so I will draw AE perpendicular to BC. Let us draw AE perpendicular to BC. We know that in an equilateral triangle, if there is an altitude, it bisects the opposite side. So the length of BE will be equal to the length of EC. It will be half of the side. If I consider the side to be A units, then it will be A by 2. Now observe in triangle AEB, we have got hypotenuse as AB. So AB square is AE square plus BE square. Substitute in the place of AB as A. In the place of AE as it is AE. In the place of BE, I can write A by 2 whole square. So I can find AE. AE square will be equal to a square minus a square by 4. So we get the length of AE as a root 3a by 2. This is the length of the altitude. Now let me consider the triangle. ADE. In this triangle, we have AD square as the hypotenuse square, which is equal to DE square plus AE square. What is the length of DE? The length of DE is BE minus BD. They have given that BD is 1/3 of BC. So 1/3 of BC is nothing but A by 3, and the length of BE is A by 2. A by 2 minus A by 3. If you simplify, we get A by 6. So let me continue here. So the length of AD square will be, instead of BA, I can substitute, instead of DE, A by 6 whole square, plus instead of AE, in the previous we have got root 3 by 2 A. So substitute that, we get AD square as A square by 36 plus 3 times A square by 4. Take the LCM and cross multiply. 36 times of AD square will be equal to A square plus 4 9 times. So we get 27 A square. So 36 AD square will be equal to 28 times of A square. Divide both sides by 4. We get 9 times of AD square as 7 times of A square. A square is nothing but AB square. Hence proved. Question number 16. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square on its altitude. So we need to consider an equilateral triangle and altitude of the equilateral triangle. If I mention the triangle as ABC and the altitude as, say, E, we have B equal to EC. This is A by 2 if I consider each side to be A units. This is because in an equilateral triangle, the altitude acts as a median. Observe the triangle AB. In triangle ABE, the hypotenuse is AB, so AB square will be equal to AE square plus B square. So AE square will be, AB square is nothing but A square minus B is nothing but A by 2 whole square. We get the length of AE as a root 3A by 2. Now let me find AE square on the altitude. It will be 3 times A square by 4. If I cross multiply 4 AE square equal to 3 times of A square. A square is nothing but some side square. So we have got the result, 4 times the altitude square will be equal to 3 times the square of each side. Hence we have proved. This is the last question, 17th question. We need to take the correct answer and justify if in triangle ABC, AB is 6 root 3 centimeter, AC is 12 centimeter, BC is 6 centimeter, and the angle B is, let me consider AB square. Let me square that. We get 6 root 3 whole square, nothing but 36 times of 3, 108 centimeter square. Let me find AC square. Yes, 12 square, we get 144 centimeter square. BC square is 6 square, nothing but 36 square centimeter square. Now observe, we get AB square plus BC square as 108 plus 36, nothing but 144, which is AC square. Therefore, angle opposite to AC is 90 degree. Which is the angle opposite to AC? Angle B is 90 degree. Therefore, the option C is the right answer. With this, I have completed the triangle chapter. There is one more exercise which is optional. You can try those questions. In case any doubt, you can send a mail. In the next session, we shall take up the questions from NCERT exemplar. I'm keeping these videos little lengthy so that more and more questions are solved and easily you can prepare for the examination. Thank you.